So if you remember, we have to locate two places on the line that hit where? Hit in the corner. All right, good Saul. Could you come up and touch one of those places that hits a corner? You all see them in your work? Nice. Let's make that a little bit. Actually, recognize that shape. See if that did anything. It doesn't recognize it. Look with the line. Hold on. It's not doing that. Never mind. Doesn't recognize it. Okay, that's a point. All right, where's another point? Great. Go ahead and try it. Maybe we're going to look a little bit better. Oh no. Wait. Okay. No, that's good. I don't know. The thickness I changed. I gotta mess around with it, see what the difference is. All right, so 2 points on there. Now, if you got to recognize 2 points, any 2 points, you can figure out slope. All right, can you see it? You go from 1 point, go. Which point we want to start on? Does it matter? Okay. First of all, can we tell, is that line positive or negative? That's a little bit better. It's, what did we say, positive or negative? It's positive because from left to right you're going up the hill. Very good. Okay, so we go any point. Let's start in the bottom one. To get to this one, how many boxes do we have to go up? 2. And then over 1. So the slope would be 2 over 1. It's rise over run. Okay, now if let's say that I start on this point, we would go down 2 and to the left 1. So it'd still be 2 over 1. Don't worry about your negatives. Just determine at the very beginning whether it's positive or negative. That way you don't have to think down to negative. So we know this is positive and it has a slope of 2. Pretty easy? Okay, so any graph we just have to recognize any 2 points and then go up together and over and figure out what that slope is. All right, good. All right, review the distance formula. Does anybody know it? We're going to have a quiz over 3.4 and 3.5 Friday. Okay, I'm going to go. Hopefully, we'll get through 3.5 today. We'll work on it tomorrow, and then review it again, and then we'll have a quiz on Friday. Yes, sir. You remember distance formula? X1. All right, go ahead and pause it. Good.
X1 minus X2 squared, so
Very good.
plus y1 minus, parentheses, y1 minus y2 squared.
Okay. Now I actually think that the book says x2 minus x1. Is that correct? All right. Does it matter? Doesn't matter. Okay. Because we're going to square it anyways. So if we were to ask you find the distance from between points 3, 4, and then say negative 2, 6. All right. What would go inside the first set of parentheses? Charlie?
3 minus negative.
Okay, good. Good. 3 minus negative 2. What would go in my second set of parentheses? It's all. Subtracting the y's. 4 minus 6. All right, so we subtract them and square them. When we subtract this and square it, what do we get? We've got 3 minus the negative 2. We subtract it and square it. We would get what? Movie? 25. Very good. Okay, and then 4 minus 6 squared would be what? Nathan? 4 minus 6. Oh, is that the final after you square it? Yes. Negative 2 squared, we have 4. So distance is equal to the square root of 29. And then from there, we just put it in your calculator. Okay? Good on distance formula? All right, what about midpoints? When we find midpoints, how do you find the midpoints? And actually, let me go back to that, because Eric, you were right. You said a process that was a little bit different. Actually, let's write this, and I'll go back to tell you what you said was right. How do we find the midpoint? For instance, if you ask the midpoint of 7, negative 3, and 4, 1. Okay. What are we finding? There's a word I use for it. Midpoint is the same as finding average, right? You're just finding the average. If you remember that, find the average of these two numbers. So 7 plus 4 divided by 2 will give me the midpoint of my x. And then negative 3 plus 1 divided by 2 will give me my y. Now here's what you said, Eric, and I thought about it afterwards, and you were right. You said, I think you said, add your, well, this was back when we found the first midpoint was between 2 points. It was something like, what was it, 4 and 8. And you said divide this one by 2, divide this one by 2, and adding. Actually, you're right. And you changed the process around. Instead of adding first and then dividing by 2, if you divide both by 2 and add them, you will get the same answer every time. So that will work. Fine. Questions? Yes, sir. You what?
Why you subtracted them?
Okay, here's the thing. To find midpoint, you want to find the average. If I subtract them, I won't get the number in between them. If you think of it out logically, let's just think about number 7 and 4. Okay. Right, there's a difference. Remember, if you think midpoint, average, midpoint's in between. 7 and 4, if I were to subtract them, it would be 3, and then divide by 2 is 1.5. Is 1.5 in between 7 and 4? No, so I can always think it out logically whether that works or not, because you might question yourself, do I subtract or add? And then just check it out to see if it is in between. All right, when we do this, we get 11 divided by 2. I think Eric asked, can you have halves? Yes, you can, especially when we're in between. So 11 divided by 2 is 5.5. Negative 3 plus 1, we get negative 2 divided by 2 would be negative 1. Okay, so we move it. All right, then we have slope formula. That's only on one, and you have some postulate. Okay, slope formula between 2 points. Find the slope between points 4, 2 and negative 3, 4. The formula for slope, we use the letter M. What's our formula for that one? Remember yesterday?
Yeah, for n equals r line y2 minus y1 over x2 minus x.
Okay, now does the order matter in this one? It does, in that I have to go in the same order. It doesn't matter which y's I subtract, but if I start with, let's say, subtracting 2 minus 4, I have to go in the same order and take 4 minus this one. Okay, so the order matters. Back here, we're squaring it, so it's gonna, the sign's gonna be positive anyways. Here we gotta go in the same order. Okay, so if I took that 2 minus 4, subtracting my 2y's, what would I have to subtract then in the denominator? 1 minus 4. We'll go in the same order, right? Good. 4 minus negative 3. All right, and what would be our result?
Would
Yes.
it be negative 3 since it's x?
No, well, I took 2 minus 4. So I took this y and subtracted this, then I have to start here and subtract that one. That's where I'm saying the order does matter. If I start here, I've got to start here. Now I could have done 4 minus 2, and it will give us the same answer. I'll show you. 4 minus 2, and then do negative 3 minus 4. All right, we do this up here, we get 2 over 7. Here we get, well, that's a negative 2. Okay, negative 2. Remember, if one part of the fraction is negative, that makes the whole thing negative. And this one, we just get a negative in our denominator, but still the same result, negative 2 over 7. So just wanted to make sure you go the same. All right, then we had relationships between slopes. Okay, if I parallel lines. What's true about parallel lines and their slopes? Movie? They have the same slope. All right, then we have perpendicular lines. What's true about their slope? Almost. Okay, let's say the slope was 4. And it's 4 over 3. Okay, slope is 4 over 3. The line that is perpendicular, the perpendicular slope to that would be what? Not quite the reciprocal. You're close. The reciprocal would be 3 over 4. What's the answer? Remember how they would go? Could they both be positive if they're crossing like this? Let's just draw it. And you figure it out. If we draw them perpendicular like this, and they're not vertical and horizontal, wouldn't one have to be positive and one have to be negative in order to draw that one? Okay, so it's not just reciprocal, it's the negative reciprocal. Okay, they're opposite signs, flip them, and change the signs. So that would be an example of a perpendicular slope. So they may give you 2 sets of points and another 2 set of points and ask you, are they perpendicular? So you would use the slope formula, and if they ended up being negative reciprocals, you would say yes. If they weren't, if they were the same, then you know the 2 sets are parallel to each other. All right, good. All right, let's take a look then at our new lesson today, 3.5. All right, this is an equation of a line. Any way we can determine whether it's an equation of a line? How do we know? Maybe you don't. Is that an equation of a line? Right? Do you know how we tell? Okay, actually, that's about right. Yes. Okay, we know we have a y and an x with a line. More specifically, our exponents, although we don't have one, what's it understood to be? It's understood to be 1, okay? So we could rearrange this to get it into what form? Remember that? What do you call it? When you get y by itself, you call it something form. Yes? Slope-intercept form, okay? But this is what we call degree 1. It's called degree 1 because the exponents are 1. Okay? Lines are degree 1. So that's how we know this is a line. Now, the first way they want us to graph these lines is by finding their x-intercept and their y-intercept. And I wish I would have kept that graph up there, but I didn't, so that's okay. We'll just sketch it. All right, let's say we have a line here, okay, that crosses the x-axis right here, and it crosses the y-axis right here. Okay, this coordinate here, we have no idea what the actual coordinate of x is. Do we right there? Do we know what the value of x is? But do we know what the y value is? What's the y value at that point? How far above the axis or below the axis is it? Well, it's not. It's right on. So the y part would be 0. Okay, so if we wanted to find this x-intercept, all we have to do is substitute 0 in for y. Okay, so we'll substitute 0 in for y to get one of these coordinates. All right, have you graphed a line before where you just put values in for x, and then you got y values out, and then you plotted those points? You recall doing that? This is similar, except for we're just going to put 0 in for x, and then to get this one, we're going to put 0 in for, put 0 in for y first. Put 0 in for y here, and we're going to put 0 in for x to get what this coordinate would be. Okay, and that'll give us our 2 intercepts. So we put 0 in there, see what our result is. Okay, substitute 0 in. What do we get? What can I do with that 3 times 0? We've got minus 3 times 0 would just be what? Would just be 0. Good. So can I take that all away?
Yeah.
Yes. So we get 2x is equal to -6. So x would be equal to -3. All right, -3. So that is one point on the graph. Okay. When we put 0 for y, -3. So one coordinate is -3, 0. And that's where we just located this. I made a rough sketch. It probably doesn't look like that. We've got -3, 0. All right, then we're going to put 0 in for our x. And we know 0 times anything, this would go away. Do I need to keep my negative sign attached to that? Yes. Anytime you have a negative in front of the number, we've got to make sure that we keep that. It stays with our expression there. All right, divide by -3. All right, remember,
So will it always be just the same numbers, just the signs are switched?
when we put them in, no. It just happens to work that out.
You always put it in for 0?
Yeah, to find the x and y intercepts, because no matter where this intersects the x-axis, won't its y value be 0 every time? And no matter where this intersects the y-axis, we know the x value is always 0. So if they asked you to find or graph it by finding the intercepts, that's all you're going to do. Put 0 in for x and y, find your 2 coordinates, plot those points, connect them to make the graph. Okay. Now they won't always, you're saying what? It ended up being the same numbers here and here?
The signs switch.
That won't be the case because this could be changed. And if that changed, that would have changed the values of these. So it just worked out to be that way. All right, so this coordinate would be 0, 2. So we've got those 2 points. We can plot those on the graph and then connect them to make them. All right. Okay, one more example, and then we'll stop there. And then if you think any questions we may have from 3.4. All right, now this is what we just talked about. Another way to graph it is to put it in slope-intercept form. Okay, slope-intercept form means y is by itself, right? Got to get y by itself. What do I do first in order to get y by itself? It's on the left side. We get rid of the 3x first, or we get rid of the 4 in front of the y first? Okay. It does matter, okay? That 4 is being multiplied by the y, right? So how do you undo something? Multiplication, you undo it by division. Now here's the problem with that. If I divide this by 4, I have to divide everything on the left side by 4 and everything on the right. And if I do that first, I'm creating a fraction, and we really don't want to deal with fractions if we don't have to, right? Okay, so the first thing, we always divide that coefficient last. That's the last one we do. So 3x, how do we get rid of that? Remember, it's a number. You would subtract it, okay? X is some number. So this could be, let's say, 15. If we had 15 more on this side, if we wanted to get rid of it, we would subtract 15 from both sides, right? This value is 3x, so we subtract 3x on both sides. All right, now in order to get it in slope-intercept form, we want that term with x to be in front. Like that, okay? Questions with that? You okay with that? This is important on that. All right, and then we would, to get rid of the 4, we would divide. Okay, so we divide by 4. We got to make sure what we do on one side, we've got to do to everything on this side. So divide by 4. Okay, now it's in slope-intercept form. What is my slope? Okay, negative 3/4 is my slope. And then the -1 would be my what intercept? Is it my y-intercept or my x-intercept? Y? Yes. Okay, this is my y-intercept. All right, and then we'll learn how to graph, which I'm sure you've had it before, but we'll refresh on that, how we graph that, knowing slope-intercept form. All right, let's go ahead and stop there. All right, if you would take out your 3.4.